Hi everyone. Here we are with Hans on another episode on TrueMLTalks. Just to briefly introduce, I'm Anurag, one of the co-founders at Truefoundry, where we are helping companies build LLM and ML ops pipelines and deploy it to production. Uh, we are proud to have Hans. Hans was the first ML engineer at Digits, where he built out the entire ML stack for Digits. And like prior to that, he also helped build stacks for companies in retail, ERP, and as well as in other areas like healthcare. And Hans is also the author of two of the popular books, Building Machine Learning Pipelines by O'Reilly, as well as the NLP in Action by Manning. So it's a pleasure to have Hans here. Just a brief introduction for Digits. Digits is a um, like AI for accounting company in the US, has raised more than 100 million, and they are trying to solve accounting for small businesses by using AI. And we'll talk into and dive into that today. Hans, over to you. It will be great to have like a quick introduction from your side.
Hey Anurag, thank you for having me. As you said, like my name is Hannes. I'm a machine learning engineer at Digits. I'm very happy to be part of that amazing team over there. And my journey started a long time ago. I was ever since high school, I was interested in neural networks. I ended up writing my thesis about machine learning in the context of energy systems. And then a little bit over 10 years ago, I came back to the machine learning world, and now then full-time as a machine learning engineer. And as you said, like I sort of drifted into this MLOps space because I felt like we need better tooling around the amazing models. And I felt like also we talked a lot about the internal models, we talked a lot about the architecture, but we rarely talk about like how do we actually build machine learning models into systems. And that is something which is really close to my heart.
Awesome. That's great and pleasure to have you, Hans. What we can start with is maybe if we can dive into some of the use cases as to how AI powers, the business for Digit, and
Mhm.
taking an example of a customer journey probably and explaining the different parts in that pipeline where AI powers. That will be a great place to start.
Yeah, so at Digits, we are supporting accountants as well as operators of businesses. So if you run a business in the United States, a small business, you can say like, hey, I want to use Digits, or you can ask your accountant, or your accountant might use Digits already without telling you. And then we support both of those use cases in various ways. And one interesting way is like we use machine learning to learn from the patterns of classifications of accountants and then support the accountants in speed boosting their work. So that has this really nice effect. Like accountants can then maybe handle 50 clients instead of 25 because we categorize things for them automatically, highlight outliers, ask for a few things where we're not 100% sure, but they get the chance to automate the whole process end to end, and they can focus on the real hard problems, or the customer problems, than just the mundane, tedious work they try to automate for decades now. And with Digits, I think we have a really nice approach how we use machine learning in combination. It's a speed boost for the operators, it's a speed boost for the accountants. So super excited about the implementations.
Okay. Curious to know, like, when you look at an accountant, like, say, an operator that you're talking about, and talk about the number of accountancy tasks that they are able to do in a day before Digit versus now with Digit, what has been the impact? Like, would be great to kind of know that.
It's I don't have like the numbers. I would say the typical customer they're able to double their customer base. But what we hear from customers is that they come back to us and say like, this makes us look really professional. This makes us look really good because their response time to their customers is extremely fast. We built a machine learning tool where the accountant can chat with the owner of the small business. And when they sometimes even the accountant doesn't know what the correct classification for a transaction is. It usually happens around checks and things like this, where you just see like a little line that says like check and then a number, right? And we built them a tool where they're like, hey, why don't you just ask the question? And we use generative machine learning to write the questions for them, so they can just click on the button and say like, yep, I like this question. I like this professional tone, or I want to have a friendly message or something like this. The message goes out to the operator responds, and even before the accountant gets notified, we had reclassified their transactions based on the response. And for them, when they see this, they were like, hey, wait a second, this is like machine learning and AI, like all through this workflow, and at every step we speed boost them. But the cool thing is, what I really love is like they're in control of like every little step. Right? We do not send the messages automatically. We do not automatically book things. The accountant on that side of the product is completely in control, and we're not replacing them. We're basically speed boosting them, right? And then give them more time to look into the super interesting problems. How do they optimize the tax side for the accountant, for the operators, and things like this.
Understood. So one kind of models that you end up implementing is some of the classification models based on transactions data. The other you mentioned is being able to generate the text. What are some other models that you have had to build in the AI stack to power the entire suite of these applications for these operators?
Yeah, we have, like, as you can imagine, we have the typical swath of like classification and prediction models. The typical bread and butter of machine learning, I would say. But classifications only go so far in accounting, and accounting is highly subjective. It's highly context driven. I can show you Starbucks transactions, and an accountant might say this is a meal transaction. Another accountant might come in and say like, no, hold on, Anurag, this is actually this is a travel expense, because look at this. You bought this cup of coffee at an airport. You were on the way to a customer conference. This is a travel expense. It's not a meal expense, right? So every accountant is correct in their own classifications as long as they are consistent. So having a global machine learning model, which like a global prediction model, which gives the same label at every point, is not the right approach. Like we would lose customers left, right, and center. We have to mimic them, and the way we do this, the way we speed boost the accountants and help the business owners, is by using something what's called similarity-based machine learning, where you find similar neighbors, you find patterns, and then you mimic those patterns. And that is not the typical classification approach. Validating those models and evaluating those models is a little bit harder, and building the models in the first place is a little bit harder, but it's tremendously powerful and extremely interesting from an ML ops perspective.
Awesome. Yeah, we'll dive into the similarity-based ML pipelines. Very curious to know, and I can relate to it. Like the same accountant, because something is gray, in a gray zone, can interpret it in a very different way. So I understand that point, and that's really nice to know. And amazed by the work you are doing there. So hence, like maybe it'll be good to kind of share how the ML journey really started. Like, what was the foundation of ML ops at Digits? Like, and where is it right now? And what has been the journey like? How have you transversed from a system where there was no model to something implementing similarity-based pipelines to other things? Like, I'd love to know the journey, and then we'll deep dive into the stack.
When I joined Digits was around at that time for 2.5 years, something like that. The core team had worked at Google and Twitter. They had founded a previous company. The company got acquired by Twitter and then moved on to Google. So the team had extremely good best practices when it comes to scaling data, scaling applications. Like so when I joined the team, my biggest concern was, oh God, I'm gonna have to clean up the data. That's what I have noticed, and that's what I learned in previous jobs. You usually show up and there's these great ideas about like machine learning projects, but then it takes you months and months and months and months to get the data in the first place, or to even get access to the data or things like this. That was not the case at all. When I showed up, the data was in a perfect place. Everybody has such a great background in data engineering that like my understanding of scaling was like something I had to brush up, and like people have seen much bigger problems than what we would see in the early days on the machine learning side. So it was a really good starting place. And even before I joined, the team was already implementing models. They were statistically based models. They were like decision trees. But at some point they were like, hey, we need somebody who has like a deep learning experience, who can help us
Got it.
to bring NLP into this world, things like this. And another thing which was really great about Digits when I joined, Digits is an Apache Beam company. We use Dataflow behind the scenes. There's like a lot of like Apache Beam applications for data pipelining. So when I came in and I talked about like, I really would like to use TFX because it scales really well, and Apache Beam helps us to like scale from like a small pipeline to like a big pipeline just by changing out the runner. Everybody was like nodding, and I was like, yeah, that's a great idea. We'll totally in support, right? And
Nice.
that was very unique because in previous companies, I had to introduce the benefits of Apache Beam first. And that was not the place. There was no need there. We also had we have team members who have a very deep understanding of Kubernetes. So when I came in with my need for like, oh, I would like to host TF serving and I have a container and like I have a decent understanding of Kubernetes, but like, can you help me to make this, to bring this into a zero trust network? There was great support from the team. I learned I learned a ton. That was just a great implementation. So when basically just to summarize it, when I joined the team, I just had to connect the dots. Like we used Apache Beam. There was great knowledge of scaling. There was great knowledge of Kubernetes. What my role then was like, okay, let's bring in all the different tools for like data validation, model training, model analysis, model serving, and really close the gap what the team was needing when it came to the ML space. And
Awesome.
to your last question, where are we right now? Like we're happily using a great setup of machine learning pipelines. We're happily using TFX. I'm pretty sure we deep dive into this in a little bit, but this has been running really, really well for like 12 months. And obviously we have to do some maintenance from time to time. So the TFX versions and TensorFlow versions upgrade. And also the models are getting bigger and bigger these days. So that brings in new challenges, but generally we have a really great success over the last 18 months.
Awesome. That's great to know. So maybe let's dive from here into the overall current architecture of machine learning, the entire set. And maybe we can start with the training. From what I understand, you all run things over Kubernetes. So that kind of maybe we can start there, and how kind of the training part is orchestrated, and what all do you have on the training side. That'll be great to kind of dive in.
Yeah. So actually, we need to go one step maybe earlier. Like we have an ETL process, which is gathering different artifacts from around the system to like help us to bootstrap data sets on a continuous basis. We go through in our machine learning pipelines, we go through a process of validating the statistics of the data sets, creating schemas, and then once we have the schemas and the statistics, we can use that for effective pre-processing.
Okay.
And we do that with TensorFlow Transform in our production pipelines. That has this great benefit of like, we can scale this easily. Like, as I said, before, we can run this with a direct runner very efficiently for like small projects. But sometimes we have to process massive amounts of data. So in that case, we can easily just swap out the runner and point it towards a Dataflow project, and life is good. Very little overhead to do that switch.
Right.
And we hand things over to a training step where we, it's probably not a secret, we're running those pipelines in Google Cloud Vertex. And then that moment we can use the training platform. So we have models we train, they're really, really small. They run on like 4 core machines or something like this, just CPUs. We have some models where we cluster multiple GPUs of like the state of the art together to get something in a reasonable time frame so we can actually iterate on those models. Okay. And then once those models come out of those training steps, we evaluate them automatically. We have like a validation set that is consistent for every run. And out of that validation step is we generate a custom report on our ends, generating some messages, charts, ways to allow us to compare that new model compared to the last model. Like that blessing means like the last model we have shipped to production. And then based on this, we ship this model to a model registry. And we get an automated message from our pipelines into our Slack, and says like, hey, here's a new model. Could somebody please take a look at this and validate that model? And then if that is working okay, if the team says, yep, this is worth the effort to deploy the model, we invested heavily into a CI/CD system to like not just kick off those pipelines I just talked about, but also to handle all the model deployments. I cannot touch anything in production. I have if something goes wrong, I have no control. Everything has to go through a CI/CD system, and that amazing thing is like we came up with our own configuration files for our deployments, and automated processes handling all the deployment.
We'll dive into that. So let's start from the initial part of the training. As like people are training different sorts of models, like, and especially given you are using GPUs, like how do you kind of manage the resource allocation between different folks? Like what if someone spins up like a huge number of GPUs and it kind of ends up burning a lot? How do you manage and control that? Like, is there a mechanism you have implemented internally to kind of do resource allocation, resource management? Any other best practices there?
Yeah, to be honest, the team is relatively small. That the overhead is very little to communicate this, and it's just like everybody can see how many resources you spin up.
Mm-hmm.
I can only think of like 1 or 2 cases when we ran out of resources. But we have certain limits and for the team and for the project, and that was just because like I was probably running 3 projects at the same time. One of my colleagues was running 3 projects at the same time. And then a third machine learning engineer kicked off a bunch of new projects. And all of a sudden we're like, oops, this is like way too much. We did have some issues earlier in the year regarding access to A100s, H100s machines, things like this. I think everybody in the entire industry experienced this, right? It was like the shortage. It seemed to have gotten better. And that was less constrained across the team than between companies, right? Like I heard from folks that even at Hugging Face, they were like, we can't get machines right now. Right. So, yeah.
Understood. And you mentioned about as you're training, like what do you use for logging the metrics and comparison across the training runs? Like, have you implemented an internal system? Do you use something from the open source world?
Yeah. So I think maybe I need to step back for a second. Like, we have a world view where like we say there's an experimentation phase and then there's a production phase of a machine learning model. During the experimentation phase, you can use whatever you want. You can use any framework. You can use PyTorch, TensorFlow, XGBoost, scikit-learn, whatever gives you the speed boost. Like speed in that moment is extremely critical because we need to prove that we can solve a business problem with machine learning as fast as we can. And usually the first approach is not the best one, and we need to iterate on those. So speed really matters. We also built some custom platforms where we can train remotely. So we used to use certain products from like cloud vendors. They ran in the browser. It never felt very native and things like this. It was never really like, I don't know, the browser crashed and you lost your project. Or like, ah, damn it. The experience was never really great. And so we ended up building our own tooling and using like VS Code and like running like remote instances and like having our own setup there. But once we get to a point where we say, okay, we have solved this problem, and now it just comes down to like scaling, like training this with like terabytes of training data, then we move to the production phase. And in that production phase, we try to standardize everything around TensorFlow, and there are a number of reasons why we do this. It just has a really good production tooling set. Like one thing which saved us tremendously over the last couple of weeks was like TensorFlow profiler. So when we discover there's a certain, let's say, a longer latency than what would we expect, we can evaluate the training or we can evaluate the inference, and that tooling has been tremendous. So we're trying to standardize all of our machine learning models around that tooling. And that allows us also to have like internal libraries to like sort of like standardize a number of components, layers, things like this, so that when you start up a new project, often it's like completely cookie cutter. Like everything, especially around the pipelines, it's just like, okay, let's take this base project, change a few lines, change where we ingest the data from, drop in, replace your machine learning layers or the model layers, and then hit run. And that's where we are right now, which is extremely cool.
Amazing. This seems very much like, I think FB Learner had something like workflows, wherein the different components were like almost the entire pipeline was written as different components, and you can take someone else's thing and then switch or substitute it and then just click run and things will run. So this seems very, very similar to that. I dive into the part of the similarity-based, ML pipelines, and because you talked about the validation set, I'm curious to understand, like, when you have like similarity-based ML models, the ML pipelines, how does the concept of a validation set change versus, say, a normal machine learning model that I would be running, right? Like, what are the nuances that come into choosing the validation set or the golden data set, or however you call it?
Yeah. So when it comes to the similarity-based machine learning, you have to pick an objective. Like you have to say what is close and what is far apart. And then in your validation set, you pick a large number of samples, and hopefully a human has had a chance to review them, and to say those are two samples and they're either close or they're far apart. And this could be like, in our case, the anchors could be categories. You have two transactions, you have a Lyft and an Uber, and they're both in the rideshare category. So you say like, okay, those two transactions share something. But there might be other cases where like the Lyft and an Uber might not be the same category because like clearly they're not the same company. They have different subsidiaries, they have different investors and things like this, right? So first of all, pick the context, and then second, you have, instead of having a validation set which is like input features and you have like a label you would predict, you basically have like two columns, which is like the input A, input B, and then your output is like how close and far apart would you think is that connection, and then you run through your model validation and you test whether the things you expect are supposed to be far apart, and vice versa. And then you can plot them and calculate like how many of the things you expect to be close accidentally are far apart.
Okay.
Yeah, but the thing is, it's not like in the classification case, you could easily say like, well, accuracy is a potentially starting point. It's usually not the best metric, but like it's a good metric to start and to also visualize like the effectiveness of the model. That does not apply directly, right? It's like if you have like a similarity, if your model comes back with a similarity between two data points and it says like it's 0.997 and the next one is 0.96, this might ultimately be the same, but like the values are not the same. So it's not like black and white. That makes sense. It's sort of like there's always a little bit of the gray area, and like you work with a lot of variability, and like there's a lot more parameters more than in a straightforward classification model.
Understood. And how does it get impacted with the number of operators? Like suppose like there are 100 operators versus say 10,000 operators, then the number of these pipelines will probably tend to increase, and then your similarity scores will tend to become more, and then the difference between like one and the other probably even kind of reduces. So what happens there? Like how does this validation get impacted there? Like, I'm curious. Like, this is a very interesting problem. So
Yeah. Generally, when we build the validation set, we're trying to be as agnostic of a certain industry, vertical, current data sets as possible. There's always an inherent risk that there is like some bias in there, just simply because of our like backgrounds. And I know certain brands. My colleague might know other brands. I didn't grow up in the United States. Certain brands are completely unknown to me, right? So, and the same thing for my colleagues who have been growing up here. So, like, we all have a certain bias when it comes to those validation set, but we're trying to review them in many steps to make sure that we balance each other in terms of those judgments. When it comes down to like how does the size affected? If you have like 10 operators, there's a high chance that let's say they all come from the same accountant, they're all connected to the accountant, and the accountants sometimes are super specialized. We have one customer who just does accounting for breweries, and you see a lot of interesting use cases around like brewing equipment, and then potentially there's another accountant who does the books for just veterinary practices, right? So if you start with 10 of those companies, your model might be heavily biased towards one vertical, or maybe a small number of verticals. So the bigger you spread your day training set, it smooths it out. Like that is sort of like all of a sudden your vendors from like the veterinary practice are good counterexamples to like the brewing supply companies. If that makes sense.
Yeah, I understood. This is great. Any other thing related to the similarity-based ML pipelines that tends to be very different from like a normal ML pipeline that you'd like to kind of share, Hans, about?
I think it took us a couple of iterations, and I would even say like probably months to come to an effective training, or to train those models effectively. Because everything is very strongly connected. In similarity-based machine learning, there are multiple approaches or different approaches. Generally, the easiest approach is like you have pairs of like A and B sets, and then you designate whether the samples are close or far apart. There are other approaches where, like you say, you have an anchor and you have a positive and a negative sample at the same time. So it's called the triplet loss or triplet learning. And the way you structure your data set determines your loss function, and vice versa. As soon as you change your loss function, you have to change your data sets. Right. And so initially, it was difficult for us to like make quick changes in the loss functions, because it meant like, oh, we have to rebuild all the training sets. And at the same time, I remember we had like a model we trained with like 4 GPUs, and it ran for like a day or something. We have now broken this down to, we have optimized it in such a way that we can run the exact same training in 26 minutes. Because of all the tooling around, like we optimized the way we ingest the data, we optimized the way we train it, we profiled the heck out of the model during the training, we profiled the heck out of the model during the inference. Like that is a smooth transition. But like that efficiency gain has been tremendous, but it was not something which we discovered on day one. That was like a crazy journey. So I would say if somebody else starts this journey, like keep optimizing. You will find interesting blips in your data where you can say, oh, we can simplify this here, or oh, we can pre-process this step in a certain way, which will boost the training, or like we can reduce our input tokens in case you use language models, because your input text is like limited to XYZ. So there's a lot of optimizations there. And I think in classification models, we tend not to optimize so much, because it's just like everything is heavily optimized, and you're less bottlenecked in the way you would use GPUs.
Got it. Understood. And then what do you use for this pipelines? By the way, I forgot to ask. Like, do you use like an Airflow or something like that?
Yeah, so for the definition of the pipelines, we use TensorFlow Extended.
Okay.
We were active contributors to TensorFlow Extended add-ons. It's like a community of like folks from Twitter, Apple, Spotify, and Digits, and other companies to like share components. So that has been tremendously helpful to like speed boost projects. And then initially we ran this on our own Kubernetes cluster. But then the scaling and the maintenance of that cluster got a little bit too much for the small team, so we moved everything over to Vertex pipelines, and now we can. That is like an infinite scaling. There's no limit there.
Got it. Understood. So you're using Vertex pipelines, and then what do you use as the model registry? Because you said you push models to the registry. So what are you using there?
We're using what is it called in Vertex? The model registry in Vertex itself.
Okay, you're using them from the Vertex. Okay, understood. And then once this model registry you push the models, then now how does the productionization part kind of comes into play? Like how is the serving layer kind of built? You know, and how, like curious to understand, like do you use fast API behind the hood? Do you kind of, you mentioned about the model server, like probably you don't use TF serve, probably you use TF
We
serve.
use TF serving. We do not use fast API because of the GIL. Like there have been cases where if you get especially in the case of like single requests, if you get a single request and you run a GPU under the hood, that single request will lock up the entire hardware. And then you end up doing mini batching on the server side and have like you bundle the requests and send like batches to the like inference side of that fast API implementation. But once you do this, you can go straight to like a torch serve or TF serving because that's the bread and butter of those tools. And they have been, especially TF serving has been stable and heavily optimized for a number of use cases. We had tremendous success of like running this internally. Like initially before they were like Vertex endpoints, the previous product from Google had like limitations which didn't work for us, like the models couldn't be bigger than 500 megabytes or something like this. So like, great, try to deploy a BERT model. Like that doesn't work, right? So we ended up deploying the models internally. We had our own deployment stack with like TF serving, and I think we built a really cool infrastructure around it. But as soon as the Vertex endpoints became like feasible for us, then we switched over because that allows the auto scaling over there is just amazing. And then that gave us also the chance of like we didn't have to worry about the scaling part anymore. That gave us a chance to like focus on the integration to our CI/CD system. So as I said like earlier, I cannot deploy models manually. They have to go through a CI/CD process, and the way I trigger this is by having a little configuration file which I submit to the CI/CD system, and then it checks the model, and then triggers the redeployment on those endpoints, or creates the endpoints in the first place.
Right. What is like just first on the serving layer, like and this is for the audience, like we have seen like a lot of companies still using fast API. What has been the difference that you have really seen in using say fast API versus using a model server like a TF serve, and how has it say impacted the latency or scalability? And yeah, I think maybe that should help the audience quite a bit. And why should someone consider using something like this versus going with a normal?
Yeah, I think to me it comes down to like two really important things. One is standardization and simplification. If you use TensorFlow serving, the endpoints and the payloads are always the same. Like you cannot muck with the system. Like it doesn't matter who set up the system. It doesn't matter what version you deployed. It doesn't matter. Like you always ingest it from the same place. It connects really well with the registry. The payloads are exactly the same. Everything is highly standardized. So that reduces, actually, in fact, that reduces our overhead. We have no model-specific inference documentation because it's always the same. It's like, if you wonder what do you need to submit, you can ask the model for the signature. That's another really cool tool in TensorFlow. I love that you can rewrite. We use that extremely heavily. We write like multiple signatures on the same model we ship, and then you can ping the model and say like, hey, tell me what signatures you have on it. Tell me what inputs you want, and tell me what outputs you provide. And that, in connection with TensorFlow serving, is like it's a really great setup. And then it also in my mind, it also brings in simplification, because nobody has to write the next API endpoint. So let's say we would use Fast API. I think Fast API is a great usage. It's a great project. There's nothing wrong with that. But if I would bring in a new model, somebody would have to manually write this, or like somebody would have to like at least inherit a class or something like this, and then deploy this endpoint. But that person, let's say we have like a junior person on the team, they could accidentally just like have a completely different format. Let's say, oh, they want this as a JSON format versus like raw text or like something like this. That is not possible with TensorFlow serving. So there's a lot of like simplification on that.
Got it. And how easy was it to kind of run TF serve on top of Kubernetes? What challenges did you face there, and how did you kind of get over that?
The basic setup is extremely easy. That is, you don't even have to bake your own container. You can use the standard open source container. It allows you to ingest from S3, GCP. I'm pretty sure Azure is supported by now as well. So you don't even need to host the models in the container itself. Like, that is all super easy. The thing what made it a little bit more, not difficult, but more interesting on our side was like, we have this policy of zero trust networks. So like, everything has to be fully encrypted between nodes, right? And so we had to bring in TLS support for TensorFlow serving. The cool thing is TensorFlow serving already supports TLS, so that was not the hard part. The hard part was like, how do we manage certificates, and like, how do we make sure that like the TensorFlow serving gets the latest certificate, and like we can rotate them out and things like this. So, but that was extremely productionized. Like, let's say like the TF serving setup is already running in multiple companies in those scenarios. So it was like not something we had to break new ground there, but it was a super interesting project.
Awesome. That is great to know. And then talking a little bit about, say, models running in production, and then how did you detect automatically if the models needed to be retrained? Maybe you can complete the loop as to what went behind the hood to kind of then automatically use CI/CD to move this. So I'd love to kind of get that journey.
Mm-hmm. So whenever a model makes a prediction, or whenever a major event happens, we get like notifications. We have a channel where we see like, hey, this happened. This channel is super noisy, but it's also a great way to celebrate like cool wins. And sometimes we see like snippets where like, hey, this just worked. Like this just worked for the user, right? Like, we don't see every classification. We have way too many. We run through like millions and millions of transactions on a daily basis. And so in that case, we take snapshots or like fractions of that and validate them. That's maybe another thing we'd have, like, we built like an internal review platform where we can say like, does this a model answer make sense or not? And in that particular case, when we spot like things we believe the model should handle, that is a good case for like for retraining. It's basically sort of like a quality check on the data drift versus like the we do also like calculations of like the training set versus the data which goes to the system, but that seems usually like the numbers are hard to interpret. Like, what is the drift of 0.1 of Chewy shift distance or something like this. That's super project specific. So the next time it might be a different threshold. And therefore we just like, we do have those metrics, but we focus on the quality checks to actually say like, okay, here's the thing we need to, let's validate more data, retrain the model, etc.
Awesome. Great. I think we covered quite a bit of the overall ML stack. Anything, Hans, that I missed on the ML side, like any nuances or any, from the journey, anything that you remember that was quite interesting, or that would be a good learning for the audience out there as they kind of think about building the ML stack. Uh,
Yeah,
Maybe
I
if
think
anything
one
on
thing,
more of the CI/CD, if I missed, like, I would love to kind of cover those. Yeah.
I think sometimes like the ML and the MLOps folks sometimes might be really removed from a project, right? You work on a classification model and you often work like long ahead of the implementation and like the product release and things like this. What helped us tremendously and like bringing some of those machine learning models to a great success is like working with very closely with designers and product managers and having a direct connection to a designer. So the conversation could be like, hey, you have a form. The designer comes to us and says like, I have a form that has like 4 fields. Do we actually need to ask those 4 fields or can we predict them?
Okay.
Can we get rid of the entire form? Can we make this, if that's not possible, can we make this like a 2-form field or a 2-field form, right? And the same way it goes from our side. Like we come up with a new machine learning model. We go to the designers like, we really, really need a feedback loop. We need feedback from a customer whether that prediction is correct or incorrect. So can you in your design system, can you come up with patterns of like how to show predictions of how to collect feedback? Because we can do the best work if it's not shown correctly to the users. If the design is flawed, everything is flawed.
Right.
So working with the designers is extremely critical. And I would highly recommend machine learning engineers like go out, find your designers, talk to them, bridge those barriers, like knock on their doors, talk with them about like feedback loops and things like this. This is money. It's a perfect investment.
Awesome. One question, like you wrote these 2 books, what are these 2 books really intended for? Who are these intended for? And also, like, based on those and based on your journey, given the transformation that the ML space in itself has been witnessing, any thoughts for those who are beginning to build their ML ops stack, the ML infra stack at this point in time? What are some of the things that they should definitely keep in mind and not compromise just for the sake of time or anything else?
Yeah. So like regarding the 2 books, I had the great chance to co-author 2 books. One is called NLP in Action. It's a collection of learnings around natural language processing from back in the day. Like this book was written before Transformers. We just shipped it to the printer when Attention is All You Need came out, and we're like, damn it, should have waited. But
Right.
it contains like the important basics of natural language processing. And I think I often go back to the basics of like, how do we actually tokenize? What do we tokenize? How do we break sentences? Like, how do we take unstructured data and structure that into like patterns and things like this? So that was the first book. And the second book was like, once we were done and like my colleagues and I were working on applications, I felt like there was a need of like showing the tooling and of how we go from machine learning models to machine learning systems through pipelines. And that was the second book called Building Machine Learning Pipelines was the collection of learnings from that path of like, how do we go from a raw data set to a deployed model and how do we actually deploy those models? I always heard that most models don't get deployed, so I felt very strongly to change that. You also asked like what is currently changing, right? It's like
and what should like people who are starting to build the ML platforms currently keep in mind and not compromise, irrespective of whatever, right? Like time, anything.
yeah, I think 2 things are really important. One thing is we need to be really efficient on what projects we're focusing on from the ML ops side. nobody needs a cats and dog classifier anymore, because like you can just paste it to OpenAI or like some API, right? There's like generic models, those are commoditized.
Yeah.
We need to be very specific on applications, either based on proprietary data or applications that need high stringent use cases for like privacy and security, like healthcare applications, for example. Those are the perfect applications where I would invest into an efficient MLOps set. Those MLOps scenarios are still around. We still need models of retraining and things like that. But I think also on a bigger picture, like there are more applications coming in where people will use APIs like OpenAI or Anthropic and Bard and tools like this, right? So I think the role of machine learning engineers is changing from like being the creator of like who solves a business problem with a machine learning model, but we're moving to being the consultant. We consult other people on the team, software engineers, data engineers, analysts of like how can you actually use those APIs, and we can give them a quick intro of like, this is what it means to use the temperature, or this is what means what top K means, or top N, or like those different parameters, and we can guide them. We can maybe give them a one-on-one on prompting, right? And then they're off on their own, like, and they're super excited to build their own solutions for their own like domain-specific problems. And I've seen this now a number of times, Digit specifically, which I think it's extremely great because it democratizes the access to machine learning. And I think our role as machine learning engineers is more like being the consultant, being the mentor for the folks who want to understand what actually happens behind the scenes.
Awesome. That's great. Maybe that segues into one question that I had, last question around, you mentioned about the changes and, OpenAI and Anthropic. Like, what are some of the Gen AI use cases? You already mentioned about one at the start of the call, but what are other use cases? And how are you looking forward to, from an infra perspective, to be able to support this? Maybe we'll dive into detail later on, but it'll be good to kind of give the audience a teaser.
Yeah, I think there's a number of use cases in on our side. There's a lot of communication happening between the accountant and the operators, and both of them don't really want to be in this game. So the accountant doesn't know what a transaction is. They don't want to write the question. It's time consuming. The operator doesn't want to answer it, and then the accountant has to reclassify this. Like this ping pong game, what we talked about earlier. So there's a number of use cases where we use generative AI to like speed boost both sides, to make estimates of like what the question could be, what is the answer. Once the answer comes back, how can we analyze that answer? Things like this. I think those are great use cases for generative AI. In fact, we trained our question generation model before ChatGPT came out, before this was like a whole craze. Like, so we have our internal models and our internal infrastructure to host those things, which I thought was pretty cool. And also that allows us to do those things in a very secure and privacy-oriented manner. So no data is going to OpenAI, no customer data is shared with third parties, et cetera, et cetera. So this is really top of our minds. When you asked about the stack, I think the stack will change very drastically. Like there could be, I think it could go both ways, right? I see projects where it makes sense to host internal large language models. This is a whole different ballgame. Like all of a sudden, your models have like 13 billion parameters. Even the GCP registry doesn't allow you to upload models greater than 10 gigabytes anymore. How do you even host them? How do you even do mini batching and those types of things? Like, how do you effectively use the hardware underneath the hood to get the best bang for the buck? You're not spending like $200 anymore. Those instances are incredibly expensive. And you really have to have a very strong business case to make those models work. That's one thing. But I also see like, if people use APIs like Claude or GPT-4 or whatever, right? You want to be efficient. So things like memorization or caching or effective search use cases, that's where the similarity-based machine learning comes back in, are extremely useful. Like I think you can use those APIs in connection with similarity-based machine learning and provide like a tremendous product experience,
Right.
because you get the user intent through those APIs, and you connect the data internally through your similarity-based machine learnings, and the mixture between the two is just rocket fuel. Like that is just like that's a whole different product. And
Right.
so I'm super excited where we are right now. I'm super excited for the rest of the year. I can't wait to see like where the whole community ends up at the end of the year, and like what we're doing at the beginning of 2020.
Awesome. Thanks a lot, Hans. We'll love to talk about privacy and security concerns, about caching, about the how the hosting in the model registry changes, and other nuances that come with these large language models in another call. It's great to have you here. Really appreciate the time, and thanks for sharing a lot about the stack and how it has evolved at Digit. It was really a pleasure having you.
Thank you, Anurag. Thank you for having me. Really appreciate it.